Hey guys, it is Campbell here. Today we're going to be talking about matrices. So what is a matrix? Well, a matrix is an ordered set of elements, often enclosed by brackets or parentheses, that are divided into rows and columns. Matrices have many applications in the real world, such as statistics, computer science, chemistry, and physics, and they're the most important mathematical concept in linear algebra. There are a few basic rules about matrices you need to know before you're able to use them later on in your mathematical endeavors. Firstly, you need to know how to classify a matrix. Matrices are usually named using uppercase letters. Sometimes you'll see them as bold, but it'll generally be in this format. The size of a matrix is very important. To know the size of a matrix, you first count the number of rows. These are the rows, 1 and 2, and then the number of columns, 1 and 2. So this is a 2 by 2 matrix. Now, in this notation, M is generally used to denote the number of rows, and N the number of columns. So here M is 2 and N is 2. Here M is 2 and N is 3. If you have two matrices of the same size, you can perform addition or subtraction with those two matrices. For this example, I'm going to call this 2 by 2 over here A, and this 2 by 2 over here B. So to do A plus B, you simply add the elements that are in the same position. So this is going to be 5, this is going to be 8, this is going to be 8, this is going to be 6. Because we've got 2 plus 3, that's going to be 5, 1 plus 7, that's going to be 8, 3 plus 5, that's going to be 8, and 4 plus 2, that's going to be 6. So as you can see, the resultant matrix is going to be the same size as the first two matrices. Now you can also, of course, perform subtraction. So if you wanted to do A minus B, it would be the same exact operation, but this time, obviously, we're going to get different numbers. So 2 minus 3, negative 1, 1 minus 7, negative 6, 3 minus 5, negative 2, and 4 minus 2 is going to be 2. And so this is our final matrix down here. You can also multiply matrices. There are generally two ways that you multiply them. The first is by a number, which is often referred to as a scalar. A scalar is a single number that you multiply to every element in the matrix. So for example, let's take this 2 by 3 right here, and we'll call it C. So if I had 2 times this whole matrix, I would simply multiply this 2 into every single element in the list. And so the final matrix is going to be as follows. Pretty simple. And of course the resultant matrix is going to be the same size. Now this notation, let's just clean this up so it's a bit easier to look at. This notation is just the exact same as if I said 2C. Since I called this matrix, since I named it C earlier, 2C is just the exact same thing. If I called this one 2B, I would multiply 2 by every single element in this list. If I called this one 16A, I would multiply every single element in the matrix by 16. The second way that you multiply matrices is by other matrices. Matrix multiplication has a few special rules though. You can only multiply matrices if the n value of the first matrix and the m value of the second matrix are the same. So for example, I've got m1 by n1 and m2 by n2. You can only multiply these two matrices if n1 and m2 are the exact same value. And here's why. When you do multiply matrices, let's take A and B for example. When you multiply these two matrices, you multiply each element in a row by the corresponding element in the other matrix's column, and then you add these values together. So you multiply 2 times 3 and 1 times 5, and then add them together. Then you multiply 2 by 7 and add it to 4 times 2. If you're following along, I want you to go ahead and pause the video now and go ahead and try and multiply this matrix out on your own, and then go ahead and play it once you're done to see if you've got the same answer. And that's going to be the second element. Moving down to our next row, we've got 3 times 3 plus 4 times 5. And finally 3 times 7 plus 4 times 2. The resulting matrix will have the same number of rows as the first matrix and the same number of columns as the second. In other words, the resultant matrix will have a size of m1 by n2. So remember, if this is m1 by n1 and this is m2 by n2, this resultant matrix is going to have these dimensions. Hopefully that makes sense. Let's do another example just to get familiar. So here's our next example. We've got a 3 by 2 matrix multiplied by a 2 by 4 matrix. Now we know that matrix multiplication is possible because n1 has the same value as m2. And that means we also know that our resultant matrix is going to have dimensions of 3 by 4. So let's go ahead and get started. Remember, it is the corresponding element from the first row in the first matrix and the first column in the second matrix. So this first element is going to be 5, since we've got 1 times 1 plus 2 times 2. If you're following along, I want you to go ahead and pause the video now and go ahead and try and multiply this matrix out on your own, and then go ahead and play it once you're done to see if you've got the same answer. So once you've finished, this is what your final matrix should look like, and we can double check just to make sure that our dimensions are correct. We've got 3 rows and 1, 2, 3, 4 columns, so it is in fact a 3 by 4 matrix. So if you were working along with me and you didn't get this matrix, go back and go ahead and check your work. It is pretty tough the first couple times you're multiplying 2 matrices, but once you are familiar with the pattern, it does get a lot easier. Now let's review. To add or subtract matrices, they must be the same size, and you simply add or subtract the elements that are in the same position. For example, A plus B will work because they are both 2 by 2. A plus C will not work because A is 2 by 2 and C is 2 by 3. To do scalar multiplication, you simply multiply each element in your matrix by your scalar. The resultant matrix will be the same size. And to multiply two matrices, the first matrix must have an n value equal to the second matrix's m value. The resultant matrix will be m1 by n2. So once again, for example, if I have a 2 by 3 matrix and a 3 by 8 matrix, these can be multiplied, and the resultant matrix will yield a 2 by 8 matrix. If I have a 2 by 4 matrix and I want to multiply it by an 8 by 2 matrix, I cannot, because the first n value and the second m value are not the same. And that about wraps it up for at least an introduction to matrices. There are a few things that I did not cover in this video, which I can probably do later if you guys want me to. Things like the discriminant and the unit matrix, and using matrices to denote vectors and things like that. Please let me know if you guys want me to do that. Leave a comment. But if you liked this video, if you found it enjoyable, or if you found it helpful, please consider leaving a like. Consider subscribing for more videos like this. And yeah, that's going to be about it for today. And so I will see you guys next time. Bye.